A few videos ago, we discussed the derivative of the natural log function, and here's what we found. We found that the derivative of natural log of x was 1 over x, and there was a little bit more that was going on here than originally meets the eye. The reason that this is 1 over x is what we're actually doing is we're putting the derivative of the inside of the logarithmic function, namely 1, over the inside, right? And so in a general sense, we even learned that the derivative of natural log of some function u, which is some function of x, in general, we'd say u prime over u. And that was all well and good. That's a great rule to use. But there's a problem, though. See, a lot of these derivatives that will be asked that have natural log functions in there, the inside will be so ugly that it won't really be feasible to take the derivative of the inside and put it over the inside. And even if I could, it would just be really, really bad algebra. Let me show you an example. This would be a very typical test level question. The function is natural log of x times the cube root of x to the 5th plus 2. So you could, in theory, you could treat this guy right here as your u, and then f prime would be the derivative of that over itself. But if you were going to take this guy's derivative, you would have not only a product rule, but also a chain rule as well. Really nasty stuff. Well, there's something that comes to save the day that's a huge help, a really big assistance as far as natural log functions go. You might remember that there's some algebra properties that logarithms have that can expand or contract or move terms around just because it's a natural log function, or actually it's true for any logarithm. Here's what they were, and I drew these just for natural log, but these are actually true for any logarithm, but since this problem had natural logs, I just went and wrote it in terms of natural log. And they say this: if you have the natural log of a product, that's actually equivalent to breaking that up into a sum where you take the natural log of the first term plus the natural log of the second term. Division turns to subtraction, and as well as if you have natural log of something to a power, this power can move out front and become a coefficient, and then there's no more power anymore. So these three guys, we use these all the time to rewrite the log function before we even worry about taking a derivative. A lot of these problems, 90% of the work is rewriting the function, and the last step is simply differentiating it. Everything else is getting it ready to differentiate. So I see some things that are applicable here. I see a product right here that could be broken apart into addition. I see a cube root that could be written as a 1/3 power. And now we also have this issue of order. What order do we do these things in? Could I pull a 1/3 out front and finish it out that way? No, unfortunately I can't do that first because not everything is raised to the 1/3 power. So you have to be careful to do these in order. So I think the most pressing thing is this multiplication right here. So let's try rewriting this guy before we even think about taking a derivative. All right, so f of x, notice I didn't put f prime. This is still just f. This is natural log of x plus the natural log of, and I'm just going to go ahead and write this with a power exponent, x to the 5th plus 2 to the 1/3 power, like so. All right, so that looks pretty good. And so because this is now a sum, we can differentiate this term and differentiate this term separately, and then put our answers together for the final derivative. But I don't think I'm done simplifying yet. The first term is done, but I think I can keep working on the second guy. Again, notice this is still f, still f, still f. I'm not differentiating yet. Natural log of x. I think this 1/3 can be moved to the front. We have 1/3 natural log of x to the 5th plus 2. Looking really good, looking really good. All right, and I think I'm about done. Now let me ask you a question. Do you think there's anything that we could do with this guy right here? He kind of vaguely looks like a rule. I see some addition, and I see some powers, and I see some things. You have to be very careful to only use the rules that are explicitly given. Now, the only place I even see an addition sign is right here, but that's specifically for log something plus log of something else, and that's not what I have. This power here, yes, there's a power, but this rule number 3 is only if everything is raised to that power, and that's not the case for us. We have x to the 5th plus 2, and so that's not going to be applicable either. So I'm done rewriting. Now for the very last step is it's just time to differentiate. So here we go. F prime of x would be derivative of natural log would be 1 over x, as we know. The 1/3 is a tag-along constant, and the derivative of natural log x to the 5th plus 2 would be u prime over u. In other words, 5x to the 4th over x to the 5th plus 2 in parentheses. Okay, so there we go. That's this guy's derivative. You could probably rewrite it a little bit or clean it up. Not really a whole lot you could do there, but yes, this is our derivative. And notice how easy that was after rewriting. If way back up here at the beginning, if I had treated that like u and said that f prime would have been u prime over u, that technically would have been correct, but we still would have been working on the algebra. We'd be working for another 15 minutes here trying to get that algebra sorted out. But the good news is, at the end of the day, it'll wind up being the same thing as this expression here. So great news. Okay. All right, and now we're going to take a look at our last example here real quick. Our function is the natural log of the square root of x plus 5 divided by x squared plus 4. Now there's no way I would want to take this guy's derivative if this is my u, because not only is there a chain rule, but there's also a quotient rule with the chain rule. Horrendous algebra. But I look at this, and the first thing that comes to mind is those algebra properties. So I'm going to rewrite f to begin with, not take a derivative right now, but just rewrite f. So I'm going to bring this 1/2 power, and yes, this radical here is equivalent to a 1/2 power. So we'll write 1/2 natural log of x plus 5 divided by x squared plus 4. All right, and then I see this division. I'm going to break it apart into subtraction. Now see if you can spot my mistake here. This is a very common mistake I see from students. I have 1/2. I'm going to intentionally write this a little incorrectly, a little bit incorrect. Natural log of x plus 5 minus the natural log of x squared plus 4. On the surface it looks fine because I did natural log of m minus natural log of n, but what's wrong? Well, see, this 1/2 right here was actually multiplied to the entire log expression right here. So we actually have to keep this guy grouped together. Those two terms that were separated, they still need to be as a packet or in parentheses or brackets or whatnot. So you could either write it like this, or I would recommend even just distributing that 1/2 there. So I think once we do that, it'll be pretty downhill. So f of x equals 1/2. I'll try to write this kind of quickly here. Natural log x plus 5, then minus 1/2 natural log of x squared plus 4. And now we're good to go. We have individual terms with constant coefficients, just log functions, and just simple log functions. So I think I am ready to take a derivative. And so we saw all that legwork there, all that legwork, and then the actual derivative is actually short and sweet. So here we go. 1/2 times, and this will give you a fraction. The derivative of x plus 5 is 1 divided by x plus 5. Looks good. We'll group it in parentheses just to be clear so that we understand this is a quantity times 2. And then minus 1/2. Derivative of x squared plus 4 is 2x divided by x squared plus 4. And we're basically done. I see just a little bit I think I could do just to clean that up in terms of one last thing. We see right here we have a 2 and a 1/2. I think those could cancel away. But that's pretty minor there. So 1/2, 1 over x plus 5. Minus x over x squared plus 4. So again, if you felt pretty brave, you could certainly have done u prime over u for this guy's derivative, but you'd probably still be working unless you're faster than I am. You'd still be chewing away on that algebra. But the good news again is that if you made it to completion, at the end of the day, you would get something equivalent to this simple expression. So man, we love these algebra properties that breaks these log functions apart first, then allows us to differentiate.